everyone, I am Rajasri, currently pursuing BTech in Electronics and Communication Engineering at the Indian Institute of Information Technology, Sri City. First of all, I would like to thank Emertxe Information Technologies for providing us with this wonderful opportunity of embedded systems internship. As part of this internship, I have worked on washing machine simulation using PIC16F877A. In this presentation, I'll be walking you through the key aspects of this project. Table of contents. Introduction, Embedded C, microcontroller, software requirements, hardware peripherals. In Embedded C, we learned about data types, keywords, loops, operators, functions, etc. Under microcontroller, we learned about the introduction to microcontrollers, PIC16F877A Microcontroller, which we have used in this project, and software requirements for the implementation of this project, and the hardware peripherals that we have used in this project. Introduction of washing machine. Washing machines have become a vital part of everyday life, making the process of cleaning clothes easier and more efficient. This project aims to replicate the basic working of a washing machine using a microcontroller by automating steps like washing, rinsing, and drying. Now let us learn about embedded systems. What's an embedded system? Embedded systems are specialized computing systems designed to perform dedicated tasks within larger systems. They are found in everyday devices like washing machines, microwave ovens, etc. This project uses an embedded system to control and automate the different operations of a washing machine. It's basically any combination of software and hardware that is designed to perform a specific task is known as an embedded system. Now, let us learn about the types of embedded systems. Embedded systems are categorized into two types based on performance and functional requirements and based on the performance of the microcontroller. So, based on functional requirements, it is further classified into four types: real time embedded systems, standalone embedded systems, networked embedded systems, and mobile embedded systems. And based on the performance of microcontroller, embedded systems are classified as small scale, medium scale, and sophisticated embedded systems. Now, what is embedded C? Embedded C is an extension of the C programming language, specially designed for programming microcontrollers and embedded systems. It allows direct access to hardware, making it easier to control devices like motors, sensors, and displays. It is widely used to develop efficient and reliable embedded applications. To make embedded system perform a specific task, we write the code in embedded C, which helps us to get the desired output. Now, what are keywords? Break, char, int, struct, while. Like this, there are 32 keywords in embedded C. These keywords have predefined meanings and functionalities, and we cannot use these keywords to declare any variables. Now, data types. Data types are of three types: primary data types, derived data types, and user defined data types. Data types defines the type of data associated with the variable. Among these types of data types, primary data types are the most important data types as we use them frequently. Now, operators. Operators in C plays a fundamental role in programming, as we need these operators in embedded system every time. When we want to assign some value to a variable, we need to use assignment operator. And if we want to compare two variables, then we have to use relational operators and equality operators. And if we want to perform addition, multiplication, and subtraction, we can use this plus, minus, and star operators. So these plays a fundamental role in programming. Conditional statements. What are conditional statements? Conditional statements are used to make decisions in a program based on certain conditions. If, else, and this is ternary operator and switch. What is if? It will check whether the condition is true. If the condition is true, then it will execute the code inside this block. If else, it will check the condition. It will execute the block inside this It will execute the code inside this block if the condition is true. Else, it will execute this code. If-else if ladder, which helps us to check multiple conditions one by one. If none of the conditions are true, then the else block will be executed. And similarly, nested if. It will check this condition one. If it's true, then it will execute this part of code. And if it's false, then it will execute this part of code. Again, inside this block, it will check another condition. If it's true, then this part of code will be executed. Otherwise, else block will be executed. Ternary operator. It will check whether the condition is true or false and returns either true or false. And switch. Switch statement is another type of conditional control. It evaluates an expression and matches it against multiple case labels. If a match is found, corresponding block is executed. If no match is found, then default block will be executed. But there is a limitation to this switch conditional. It's only applicable to integers and characters, and it won't be applicable to floating types and strings. Loops. There are three types of loops: for loop, while loop, do while. Loops are used when we want a particular block of code to execute multiple times so that we don't need to write the code again and again. Arrays. An array is a collection of elements of the same data type under a single variable name. This is how we declare an array. We can access the elements of this array by using the array index. For example, here ARR of 0 is 5, ARR of 1 is 13, ARR of 2 is 17, and ARR of 3 is 19. So this is how we declare an array. Then pointers. What is a pointer? A pointer stores the address of another variable. Let us consider this example. That variable A, it's storing some value, and when we declare a pointer like this, it will store the address of this variable A. And when we want to store the address of the pointer itself, then we can declare a double pointer. It will store the address of this pointer. Functions. A function is a block of code that performs a specific task. This is how we declare a function. For example, if we create a function int add to add two numbers, we can call this function from anywhere in the code without writing the addition logic again and again. So the functions helps us to reuse the code. And strings. A string is a sequence of characters ending with a null character. This is how we declare a string. Generally, strings are nothing but arrays of characters. Then, what is a macro? Macros are preprocessor directives used to define constants or reuse the code. This is declaration of a macro. Now, microcontroller. A microcontroller is a compact integrated circuit designed to perform specific tasks by controlling electronic devices. It combines a processor, memory, and input-output peripherals on a single chip. Microcontrollers are found in many devices like washing machines, microwave ovens, etc., where they handle tasks like reading sensor input, making decisions, and processing data. The main difference between a microcontroller and a microprocessor is, in a microcontroller, all necessary components like CPU, memory, input-output peripherals are integrated into one single chip. For example, Arduino PIC16F877A, which is used as the microcontroller in this project. But in case of microprocessor, every component is a separate peripheral, CPU separate peripheral, and we need external memory input output peripherals to function. Now let us look into the pin diagram of the PIC16F877A. It has 40 pin layout. Out of these 40 pins, 33 pins can be used as general purpose input output. Now let us look into the specifications of this microcontroller. It has 8-bit microcontroller, 33 pins are input output programmable. Maximum operating frequency is 20 megahertz. Memory 14 KB flash, 368 bytes RAM, 256 bytes EEPROM. And it has 5 input output ports from port A to port E. Now, in port A from RA0 to RA5 6 pins. In port B, C, D from RB0 to RB7 and RC0 to RC7 and RD0 to RC7, there are 24 pins. And in port E, RE0, RE1, RE2, 3 pins. So in total, 33 pins from these ports can be used for general purpose input output. And it has 3 timers in it, low power consumption, and power will be saved. These are the ports in PIC microcontroller. Out of these ports, port B and port D are associated with LEDs. And interfacing. Interfacing in embedded system refers to the way input devices like switches are connected to the microcontroller. Now here we can see that there are two types of interfacing, pull-up interfacing and pull-down interfacing. In pull-up interfacing, when the switch is open, the microcontroller pin will read high, that is 1. And when we press the switch, it will read the value 0. But in case of pull-down interfacing, when the switch is open, the microcontroller pin reads 0. And when we press on the switch, it will read 1. So in this PIC16F877A microcontroller, pull-up interfacing is used. This means when the switch is pressed, the microcontroller pin reads low, 0. And then triggering methods. There are two types of triggering methods, level triggering and edge triggering. Let me give you an example to understand these triggering methods. Let us consider TV remote. When we press on the volume button, it will either continuously increase or decrease its value until we release the switch. That is, the action will be constantly taken until we release the switch. So that is the example of level triggering. Either it will be high level or it will be low level. It will constantly decrement or increment. But in case of edge triggering, consider power button of TV. When we press on that, it will either power on or it will either power off. Continuous action won't be taken. Either it will be switched on or switched off. So this is the difference between level triggering and edge triggering. Here LEDs. So LEDs current sourcing and current sinking. When any device provides current to the peripheral, it is known as current sourcing. As we can see here, diode should be in forward bias. So high should be given to this pin of device, so that current flows from high voltage to low voltage. So as the device is working as a source of current, it is known as current sourcing. What is current sinking? As it is 5 volts, then the pin of this device will be 0. So the current flows from high voltage to low voltage, so that as the current is entering into the device, it is known as current sinking device. So this is the difference between current sourcing and sinking devices. Now let us move into the timers. PIC16F877A has 3 timers which can be used as timer, counter and PWM. So resolution. Resolution is nothing but the width of the timer register. For this microcontroller, resolution is 8-bit. Tick, tick. It is the smallest time unit by which the timer increases its count. Then quantum. Quantum is the duration of ticks. Scaling. Scaling is used to reduce the input clock frequency. Now, block diagram of this project. We have used switch 5 for powering on the washing machine and switch 6 for the operations like pausing, stopping, and for navigation we have used switch 4, and to monitor the door status we have used switch 1. To display the status we have used CLCD, and to alert the user we have used buzzer and fan for simulating the washing machine motor. Software requirements. These are the software requirements for this project MPLAB XIDE, where we will write the code and compile, debug the programs. And this is the compiler that converts C code into the machine understandable code. This is the PIXMLab, which is used as a simulator and test the project. This is the PIC16F development board on which we have done this project. Let me open the PIC16F board. So this is the board and this is the CLCD display. This is the fan and this is the buzzer. These are the switches, switch 1, switch 2, switch 3, switch 4, switch 5, switch 6. And these are the LEDs. As I have said, port B and port D are associated with the LEDs. This is the reset button and here is the clock frequency, and there are two options to select CLCD display. One is 16 cross 4 and the other one is 16 cross 2. For this project we have used 16 cross 4. So first, in this PIC16F board, what we have to do is we have to select the board as PIC Genius and the microcontroller as PIC16F877A. Then we have to change the display as 16 cross 4 and let me keep the clock frequency as 20. Now what we have to do is we have to load the hex file. So this is the hex file for our project. Let me switch off the LEDs as we are not using in this project. So what it is showing is press key 5 to power on washing machine. Now let me show you the code. Now we will move on to this main.c file. In this, in void main function, what we are writing is press key 5 to power on the washing machine. As it is displaying that, after this what we will do is we will clear the screen and power on washing machine. Let me show you the power on screen. In this power on screen, let me press on this switch 5. So as we can see that it is printing blocks in line 1, powering on washing machine in line 2 and line 3, and blocks in line 4. It has taken some delay and then it's displaying washing program screen. So in this power on screen, I have written blocks in line 1, powering on washing machine in line 2 and line 3, and again blocks in line 4. I have taken some delay. Then we have declared operational mode as washing program screen and reset flag as reset wash program screen. So it will enter into this switch and check the case and it will execute washing program display. So let me open this washing program display. In this, what we are printing, if the reset flag is reset wash program screen, we are clearing the screen and reset flag to reset nothing. And when we press on switch 4, it will navigate through the modes. Washing programs what we have. So these are the washing programs. Let me click on this switch 4. As we can see, it is moving from one program to another program. Now, if I want to wash my delicate cloths, what I have to do is, I have written a logic here. If we long press on this, if we long press on the switch 4 and the operational mode is washing program screen, then what we are assigning to the operational mode is water level screen. Now let me long press on this switch 4. It should redirect to the water level screen. Yeah. Then in the water level screen, what we are doing, it will again jumps to this and it will execute this water level screen. And let us see what is there in water level screen. In this, there are different water levels: auto, low, medium, high, max. Again, I have to long press in this. I have to long press in this switch 4 to select the mode. So let me select water level as low. Now It is displaying. Press switch 5 to start and switch 6 to stop. Now, is this switch 5 and switch? Yeah, here we can see that if we press on switch 5, then the operational mode will be start screen. Else if I press on switch 6, operational mode will be washing program screen. So let me press on this switch 6. It will again redirect it to this washing program screen. Let me long press on this delicates. Let me long press on the low level. Now I'll press on this switch 5 to start the program. It is displaying the program as delicates and time as 26 seconds, and it has started working. Now for pause, we have to click on this switch 6. Let me show you how it started. So run program function. So in this run program, we are checking whether the door is open or closed. How we will check the door status is here. We have written the logic. As it is pull-up interfacing, if the switch is pressed, then the corresponding pin will be 0. So if the switch is pressed, fan should be off and timer should be off, buzzer should be on to alert the user, and we are printing this message. Please close the door. Door is open. And it will continuously run until the door is closed. Once the door is closed, fan will be off and fan will be on, timer will be on, and buzzer should be on. And then we will again print how much time left and in which function it is running. Again, we will display this. Then here in this, there are 3 types of functions: washing, rinsing, and spinning. So we have given 46% of total time for washing, 12% of total time for rinsing, and 42% of total time for spinning. As we have selected the mode washing program as delicates, and if we click on the auto, low, and medium water level, then it will take 26 seconds to wash the clothes. If we select on max or high, it will take 31 seconds to complete the washing. Once the washing is completed, what we will do is we will print this. If the seconds is 0, entire time is completed, then we will switch off the fan, buzzer should be on, and we will print this message: program completed, please remove the cloths, and after 1 second buzzer will be off. Again, we are assigning washing program screen to the operational mode. Let me demonstrate that. First I'll click on this switch 5 to start again. As we can see that it started again. Function is wash. If I press on the switch 1, if I press on the switch 1, as we can see, it is printing door is open, please close the door. And when we release the switch, again the display is changed to function screen. And the function is changed from wash to rinse. Once the entire time is completed, fan should be off, buzzer should be on for 1 second, And we have to print please remove cloths message on CLCD as the function is changed to spin. And then we have to again go to the washing program screen. See, program completed. Remove cloths. Buzzer is on for 1 second and fan switched off, and again this washing program screen is displayed. Now this is the code, entire code, and based on the different washing program and water levels, time will be assigned to each operation. And let me go to the header files. This is the CLCD header file. Have predefined modes, high, low, ports, and defined each function here. This is the digital keypad.h, DDRs. This is the main.h. We have defined every function here. Timers.h and washing machine.h. These are the functions we have used in this project. CLCD.c, digital keypad.c, ISR. This is the interrupt service routine. And this is the main.c. functions. Now again, if I want to click on some operation, you can click on wipes, double click on this, long press on this. You can select the mode. Again, this process continues. Pressing switch 5 to start. Then let me move to the conclusion part of this project demo. The washing machine project using the PIC16F877A microcontroller provided a practical platform to apply embedded systems concepts. It offered hands-on experience that reinforced theoretical understanding and improved hardware interfacing skills. This simulation-based approach laid a strong foundation for future projects in automation and real-time control systems. This internship has helped us realize that hardware is not always essential to implement embedded systems. With the right software tools, we can effectively design real-world applications. Thank you to Emertxe for guiding us to look forward to a future in embedded systems. Thank you.